All right, AB assignment 1214. This is a free response worksheet to help you get ready for your practice tests. It has a few problems on it. You guys should be at the point where you've seen all the kinds of different free response problems several times, many times, done them on practice tests, done them on assignments. You should be trying all these on your own first. And then I'm going to go over them, talk about the grading, talk about the things you need to make sure you have to get full credit. Okay? It's not about just getting the right answer. The right answer is worth like a third of all the points on each of these. So the setups, the work is extremely important. These are all no calculator problems. And so the point breakdown on this one's 2, 4, 3 to add up to 9. Let R be the region in the first quadrant, closed by the graphs of fx 8x cubed, which is, they don't tell you which one it is, but this is the one that looks like a cubic, right? Cubics look like that. And the other one's a sine graph, and this kind of looks like a sine graph, right? Keeps going like that. So that's going to be gx equals sine pi x. Now, if they hadn't drawn the picture, I would draw the picture, but I'm thankful that they drew the picture. I still need to figure out which function's which, and I would label them. They also gave us the intersection points, so that's another nice thing. So it says write the equation of the tangent line. Should be pretty basic kind of task. Tangent line to the graph. So we want the tangent line at x equals 1/2. Now we have the x value, we need the y value and the slope. And this is for f. So that's for that one. So the y value, you can plug 1/2 in, and you're going to get 1. And then you're going to take the derivative of it, and that's going to be 24x squared. And you're going to plug 1/2 into that. And so you're going to get 6 for the slope. So your equation of your tangent line is y minus 1 equals 6 times x minus 1/2. And just leave that answer the way it is. Now, I haven't given you guys a ton of room on this, so we'll squeeze it in there. So there you go, 2 points. 1 point for getting the slope correct, and 1 point for getting the equation of your line correct. Part B, find the area in R. Now we can do vertical slices or possibly horizontal slices. I don't think you're going to want to do horizontal slices without a calculator because it's going to involve inverse sine, which you don't know how to integrate. So vertical slices is probably going to be the way to go. Even with a calculator, probably vertical slices would be a little more convenient. So the area is going to be from left to right, 0 to 1/2, x coordinates. Y top is the sine curve. Now you could just write g there. They would be fine with that. G, sine minus, this all needs to be in parentheses, even if you put g's. Y bottom is the cubic, 8x cubed dx. So the setup is 1 point, but we get to do these by hand this time. So we have to integrate it. The antiderivative is going to be worth a point. So this is going to be negative cosine pi x. There's going to be extra pi, so we need 1 over pi to cancel it. Minus 8x to the 4th over 4, which makes that 2. So you get a point for getting the correct antiderivative. And then we're going to plug these values in. So negative pi cosine of pi over 2 minus 2 times 1/2 to the 4th power minus, now I'd put parentheses around all this stuff, and don't just assume plugging 0 in gives you 0, because it doesn't this time. So there we go. Now this is 0. Cosine of 0 is 1. Cosine of pi over 2 is 0. So what's left is this. This is going to be 1 over 16. So it's going to be negative 1/8 plus 1 over pi. That's your answer. No calculator this time. 3 points. Or, 4 points. So let's see. Where are the points at? 2 points for the antiderivatives. Maybe one for each. 3C, write but do not evaluate. Underline that. Don't do extra work. And if you do extra work, one, you're losing time that you should have used, and two, your extra work, if it's wrong, could be graded against you. Write but do not evaluate an integral expression for the volume of the solid generating R's rotated around the horizontal line y equals 1. So this is a horizontal line y equals 1. I feel like my picture isn't too crazy that I could draw that. So we have our sine curve, and then we have our cubic, and I think we're going to probably want to go with horizontal slicing. I could show you guys the other slicing on these just for fun. The volume is, in this case, they're perpendicular axis of rotation, so it's going to be pi r squared minus pi dx minus pi little r squared dx is the volume one slice. Integrate it to get all the slices. The limits are left to right, 0 to 1/2. The big radius right here, this is the little radius, is y top minus y bottom. So y top is 1 minus y bottom is the cubic, 8x cubed. Or you could write fx in there if you want. Squared, dx, don't forget the squared, minus pi, 0 to 1/2. Little radius is y top is 1. Y bottom is the sine curve, sine pi x dx. And that's it. That's your answer. Oh, almost forgot my squared. Even if you wrote it up here, forget here, you're going to lose a point. You could, like I said, have put 1 minus fx here if you wanted, and 1 minus gx. They'd be okay with that. They named them. So you could do that, a little less writing, maybe a little less opportunity to write something down wrong. So you could do that instead. Now, the other way, just for fun, now the points on this, that was 3 points. So 1 point for the limits and the constant, and 2 points for the integrand. So that's the stuff inside. Now you got to have the constant limits correct on this one too to get that point. And then you have to have both your integrands, what's inside the integral, correct. Now, if we were to do horizontal slices, you would get shells, and it would be 2 pi r h dy, and you should get full credit on this one. And since you're not going to solve it, since you're not going to find the answer, then you should be fine. The limits are going to be 0 to 1. Now, the radius of your shells is y top minus y bottom, and y top is always 1. Y bottom is whatever y value we're at. The height is the thing that involves the curves. It's x right minus x left, but they need to be in terms of y. So x right, you'd have to solve this. You would say, okay, well, that's y over 8 equals x cubed, and then you take the cube root of both sides, right? So that would be the cube root of y over 8, all inside of the cube root, unless you want to simplify it to the cube root of y over 2. That's fine. Minus x left, so we got to solve this. You would take inverse sine of both sides, right? And then you would divide by pi. And so that would be 1 over pi inverse sine of y dy. So that would be your setup. You could get full credit for it with horizontal slicing. And you could have done the area with horizontal slicing, and it would look very similar to this. I think it would just be the area with horizontal slicing, but you would have been stuck. It'd be 0 to 1, x right minus x left. It'd be cube root of y over 8 minus 1 over pi inverse sine of y dy. The problem is you can't integrate this by hand. If you had a calculator, you could do it. So that's the first one. And so on average, these should take about 15 minutes. Some might be faster. Like, I don't know, I could see that one being a 10-minute one and maybe another one be a 20-minute one. Particle moves along the x-axis with position at time t. So they're giving you the position equation. 0 to 2 pi are your endpoints. Find the time t when the particle is farthest to the left. Justify your answer. Farthest to the left, you should automatically be thinking that's an absolute max or min of some kind. Farthest left, what is that? That's absolute min position. That's absolute min of x, right? Because furthest to the left would be the most negative or the smallest positive answer. So that's what we need to do. We need to do EVT. So we have endpoints and endpoints. I'm writing all this down very carefully. We need to find critical points. So I'm writing down critical points. I'm not abbreviating things, writing initials. Critical points happen at the derivative of the thing that you're trying to maximize or minimize. So that's a product rule right there. That's e to the negative t cosine t plus sine t times derivative e to the negative t is negative e to the negative t because you have a little chain rule there. And then we need to set this equal to 0 undefined. This usually could be worth like a point. Now, by the way, the point breakdown here is 5 and 4. And you just got 2 points for finding this derivative correctly. You got another point for setting it equal to 0 undefined. You better label it so we know what it is. That's 3 points right there. Okay? So now we need to solve this without a calculator. Oh man. Well, let's see if we can simplify it. This is cosine minus sine all over e to the t, right? Those are fractions. Equals 0 undefined. Now undefined would come when you divide by 0, which is not possible. And this comes from the top. So when does cosine equal sine? What's a reference angle? Pi over 4, root 2 over 2, root 2 over 2, right? What quadrants? Are they both the same sign? Quadrant 1 and quadrant 3, they're both negative, which would make this true. So t equals pi over 4 plus, now by the way, we usually do pi over 4 plus 2 pi k and then do the third quadrant. Pi over 4 happens exactly halfway. Like quadrant 3, well, I don't know. Let me back up on that. So that's quadrant 1. Quadrant 3 would be 5 pi over 4, right? Plus 2 pi k. So yeah, like these happen. We could just write pi over 4 plus pi k for all of them. It doesn't really matter. But that's just something that you could do. So pi over 4, 5 pi over 4. Next one would be 9 pi over 4. You could go negative 3 pi over 4. We want all of them between 0 and 2 pi, so that's these ones. Okay? So then we're going to make a table. Time. We're going to plug them into x, the thing we're trying to minimize. I'm going to write the x equation down, e to the negative t sine t. I'm going to put the endpoints and the critical points. And I'm going to plug them each in here. So sine of 0 is 0 over e to the 0 is 1, but that's 0. Sine of pi over 4 is root 2 over 2 over e to the 4th. So that's root 2 over 2 times e to the 4th. 5 pi over 4, sine of 5 pi over 4 would be root 2 over 2, but it's in third quadrant, so it's negative over e. Shoot, I see I messed that up. This should be e to the pi over 4. 5 pi over 4. So this is the same thing as negative root 2 over 2 e to the 5 pi over 4. And then 2 pi, sine of 2 pi is 0 again over e to the 2 pi is still going to be 0. Now, those are some ugly values, and you don't have a calculator, and you're like, oh, do I have to like estimate these? Okay, now you're looking for the smallest one, right? This is the smallest one. It's the only negative one, right? So now I'm going to write a nice, thorough answer. I'm going to say the particle is farthest to the left, and I'm going to put what its position is, negative 2 over 2e to the 5 pi over 4. Are there units on this problem? No. Okay. Don't make up units if there aren't units. At time t equals 5 pi over 4. So that's your answer. By extreme value theorem, do not abbreviate. Write it all the way out. And that's not enough. You got to explain how it works by checking endpoints and critical points. Don't write initials. Write it out. So unfortunately, all that rest of that work is worth 1 point because we got 3 of the 4. Or actually, hold on. 1 point. Okay. 1 point for the answer and 1 point for the justification, and that includes the work backing up your justification. So that's just EVT. Do the work. B, find the value of a constant A for which xt satisfies the equation A x double prime t plus x prime t plus xt equals 0 for 0 to 2 pi. We're trying to figure out what A is in this equation that makes this true. Well, the first thing to do is to probably find all these x things and plug them in and see what happens. So we already have x t. We need x prime t, which I think we just figured out over here, right? So we could just write that down again or not even necessarily write it down. We're going to end up plugging it in. I'm going to clean it up. So e to the negative t cosine t minus e to the negative t sine t. So that's x prime. And then we got to find x double prime, which is going to be even messier because we got 2 product rules here. So e to the negative t. So this is really a test of, like, are you really good at derivatives? Are you really good at product rule? Are you good at exponentials, trig? And you're going to get a lot of points here if you're good at all those things. Negative sine t plus cosine t times root of e to the negative t is negative e to the negative t minus, now I'm going to put parentheses around this, e to the negative t cosine t plus sine t times negative e to the negative t. And I got to distribute that subtraction. So let's see if we can clean this up. Are there any like terms? E to the negative t, negative sine t, e to the negative t sine t, it's negative, but then it becomes positive. So this one's negative, now it's positive, so they actually cancel each other out. Well, that's nice. And then we have a cosine t, e to the negative t, and we have a cosine e to the negative t, but it gets a negative, so they're both negative, so it's going to be minus 2 e to the negative t cosine t. So that one worked out pretty nice. Now, by the way, point-wise, this work right here, that was worth 2 points. The first one wasn't worth any points because you already got 2 points for it on part A. So I'm not going to give you points for doing the same thing again. So now what I'm going to do is I'm going to plug them into this equation and see what happens. Substitute them in. So we're going to get negative 2 e to the negative t cosine t plus x prime was e to the negative t cosine t minus e to the negative t sine t, right? Plus the original equation, e to the negative t sine t equals 0. Now, just the act of plugging those in, hey, you get a point. That was a good idea. That was important. You have to do that. Now, can we simplify anything? Look at this. Negative e to the negative t sine t, positive e to the negative t, those cancel each other out. We cannot combine these together because this one has an a in front. So, but what we could do is we're trying to solve for a, right? We could factor, actually, Yeah, let's factor out the e to the negative t cosine t, because they both have that, and then this has a negative 2a left over, and then this one has a 1, and it's supposed to all equal 0, right? Now, there's several ways we can make this statement true. We could say, well, when t equals pi over 2 plus pi k, then it equals 0. Okay, fine, but that doesn't help you find a. It can also be equal to 0 if this equals 0, right? So we get a equals 1/2. Get a point for that, for doing your algebra correct. Okay, so that was kind of a interesting, little different problem involving motion. Okay, let's try the one on the back. You should have tried it already, but we'll go ahead and do it together. Are you getting faster at these? Better at these? Can you do these in 15 minutes or less on average? Okay, so continuous f, defined, -4 to 3. Graph consists of 2 quarter circles. You guys see the quarter circles here, and a line, which the reason they're telling you that is you're going to probably be finding the area of those to help you find integrals, because they're not going to give you any equations, that you have this picture. So you're going to be able to find exact answers. Just because something looks like a quarter circle on a problem they give you doesn't mean it is unless they tell you, but they told us that these things are true. Then they give you this other function g. Now, you should have seen enough of these by this point now in the last couple of weeks to be like, oh, this is going to be the derivative of g. This is a derivative graph of g, right? Because g is the integral of f with some other extra stuff. So somehow this is going to be related to that. Now, part A, which looks kind of typical to some problems we've done like this before, we're just going to plug -3 into this. And we're going to find the answer. So it's -6 plus, now looking for the area from 0 to -3. So that's this area right here. And it's a quarter of a circle. So it's 1/4 pi r squared. The radius is 3, positive always. The thing about this is, yeah, that's positive area, but look at your limits. They're going backwards. They're going from biggest to small. So we have to put a negative there. And that would be a common mistake. So -6 minus 9 pi, 9/4 pi. That's your answer. That's g of -3. That's a point. Point breakdown here is going to be 3, 3, 1, 2. So that's a point. We're going to find g prime. It says find g prime of x and then evaluate it. So a lot of times they don't have you do that first point. You just got to do it yourself. But here they're going to probably give you a point for it. So g prime of x, we're going to take the derivative of this. So the derivative first term is 2, and then plus, and then derivative of integral is fundamental theorem of calculus part 2. So they undo each other, and then you plug the limits in, but then you got to multiply by the derivative of what you plugged inside. That's a chain rule thing. So what happens is that g prime of x equals 2 plus f of x. That's a point. And then they tell you to find -3. So we plug -3 in here, and we get 2 plus f of -3. And so that means look at the graph. F of -3, this is graph of f, is 0. So the answer is 2. So that's a point. So that wasn't too bad. Didn't have to explain or defend or justify. B says determine the x-coordinate of the point at which g has an absolute max on the interval. Justify your answer. So we're looking for absolute max. We have endpoints, right? And this is for g, though, absolute max g. We have endpoints, and I think it's a continuous function, so we should do EVT. Why are you not going to do EVT? Only reason you don't do EVT is if you can't do EVT. So we have our endpoints, and we need to show this work nice. This is worth 3 points. We need to find critical points. Now, the way we find critical points is say, okay, well, we want g prime of x, which we've already written down up above as 2 plus f of x, and we want to set it equal to 0 undefined. Writing this is usually a point. You need to write g prime. You need to write it equals 0 undefined. You need to do it. So just writing g prime equals 0 is worth a point. If you don't write it, you lose that point, even if you're doing that work. Okay, so now we got to solve this and say, okay, well, where does f of x equal -2? Well, where's f of x undefined? Now, f of x is not undefined anywhere between those endpoints. When does it equal -2? You're like, well, here's -2 right there. Now, I don't want you to guess what the value is up here, okay? This is a straight line, so we should be able to use the slope to figure out the point. So the slope is, let's see, the slope equals down, this is 3, this is 0, 3, right? Down 6 over 3. Down 6 over 3 is -2, right? And so then we're going down 2 over 1, down 2 over 1, down 2 over 1, but we're only going down 1, so we got to go over 1/2. So that's exactly halfway between these because of the slope. So that means that x equals 2.5, 2.5, 5/2 based off the slope. That's worth a point. So that's tricky. Don't eyeball it. Use the slope. That's a straight line. Slope has to be maintained, right? Okay, so now we need to make a table. So we're going to make a table. Just make it right here. We're going to put x values in to g. And remember, g equals 2x plus 0 to x f of t dt. And the endpoints are -4. Critical point is at 2.5, 5/2. 2.5. And the other endpoint is 3. So we just have those 3 values. Now, we're going to plug -4 into this. So we're going to get 2 times -4 plus the integral of 0 to -4 of ft dt. So that's going to be -8 plus. Now, the integral from -4 to 0 is both of these added together, but we are going backwards. So it's going to be negative. We get a -1/4 pi r squared for that little quarter circle plus 1/4 pi r squared with radius of 3 for the big circle. It's positive because it's above the x-axis, but then we got to make the whole thing negative afterwards because we're integrating backwards. So this is going to be -8 plus pi over 4 minus 9 pi over 4. So we could simplify this. -8 minus 8 pi 4 is 2 pi. So it's a very negative answer. Probably not going to be your max, but we'll see. Then we're going to do 5/2. Now, this one is being integrated forward, so we don't have to worry about that changing it. So we get 5 plus the area from 0 to 5/2. So that's that's all of this area right here, right? And so it's going to be positive 1/2. Base is 3/2, 1.5. Height is 3 minus 1/2 because it's below the x-axis. The base of that triangle is 1.5 to 2.5. So the base is 1. The height is 2. So we're going to get 5 plus 9/4 minus 1. So 4 plus 9/4 or 16/4 plus 9/4, 25/4, 6 1/4. So this is kind of a little, the geometry here is a little demanding. I'm going to plug 3 in. So we're going to do 2 times 3 plus 0 to 3 of ft dt. And so we're going to get 6. We're going to do in the area from 0 to 3. Now, the nice thing about this one is you guys realize this is a triangle, 1.5 times 3, 1.5 times 3. That one's positive, that one's negative. They cancel each other out. You get 0. So where's the max? This is the max right here. Right? Barely. A little bigger than the other endpoint. So we're going to put that in the answer. We're going to say gx has an absolute maximum of 6.25 or 25/4 at x equals 5/2. There's no units on here. By extreme value theorem, checking endpoints and critical points. You gotta write it all down. Name it, explain it. So you got a point for setting equals 0. You got a point for getting your critical point, and then you got a point for the work and the answer and the justification. C, find all the values of x on interval -4 to 3 for which the graph of g has a point of inflection. Give a reason for your answer. So we had this on a recent practice test, and I probably took out some points for some of you guys' lack of the justification. And it's not second derivative test for relative extrema because we're not looking for relative max and mins. We're looking for inflection points, which involves the second derivative. So we're looking for inflection points from -4 to 3, not including the endpoints. We can probably figure it out pretty easily. Most of you guys figured it out. So this is equal to g prime of x. G prime equals 2 plus fx, right? So f equals g prime minus 2. So this is a little interesting. This throws a little wrinkle into it. This is the graph of g prime, but shifted down 2. Okay, so I don't know. We'll have to keep that in consideration. The g prime graph should be this graph moved up 2 units. Now, this is essentially the graph of the derivative. So the second derivative is going to be the slope of this graph. Now, realize right here you get a vertical tangent. Here you get a horizontal tangent, you get a corner. G double prime right here is undefined because it's a vertical tangent. It's infinitely big. Here G double prime is positive. Here G double prime is positive. The slope is going up. Here G double prime is negative. Here G double prime is undefined. Okay, now you can get critical points when it's 0 or undefined. So we're going to look for where G double prime equals 0 undefined, which happens at x equals -3 and 0. Now I can tell right here from this picture, it's going from concave up to concave up. That one is not an inflection point. This one's going from concave up to concave down. That one is a critical point. So last test, a lot of people ignored G double prime equal undefined as a potential inflection point, but that's all you have this time, and that's it. Those can be inflection points. So we're going to say gx. I think it's good to write this stuff down. G double prime equals 0 undefined. These are the values, but we're going to have to put this all in. Gx has an inflection point at x equals 0 since G double prime of x. Well, you might say, well, what's G double prime? Okay, this is interesting. So since this is G prime of x, G double prime of x is going to equal f prime of x, right? So G double prime of x equals f prime of x. equals the slope of f. You need to somehow connect what you're saying to the original graph they gave you. They gave you the graph of f. So how do you use the graph of f? You can't just tell me g del prime is positive. Well, how do you know that? Connect it to the information they gave you. That's part of it, okay? G double prime, which equals f prime, which is the slope of f, which is what we have, is positive on the interval -3 to 0. Don't say -4 to 0 because it's not positive at -3. It's undefined. And we could say, therefore, G is concave up. I don't know. This might be more than necessary. And G double prime of x equals f prime of x equals the slope of f of x is negative, less than 0 on the interval 0 to 3. Therefore, G is concave down, and the concavity changes direction. Concavity of g of x changes direction at x equals 0. Be specific when you're saying things. Don't just say the slope. The slope of what? Slope of g, slope of f, slope of f prime, right? Don't say it. Don't say, just the slope. Like, of what? You got to be specific. Now, that was 1 point total, so I don't know. I think I potentially went a little overboard, but, I always like to just try and be safe. Let's see. D says find the average rate of change. Average rate of change. Rate of change is what derivatives measure, right? So this is average f prime or whatever. Average rate of change of f on the interval -4 to -3. Okay, it says find it. Okay, well, let's find it. F prime average equals f of 3 minus f of -4 over 3 minus -4. F of 3 from the graph is -3. F of -4 from the graph is -1. So we get -2 over 7. So that's point. Now, the other way you could do it is you could do f prime average equals the integral of f prime of x dx from -4 to 3 and divide by the base of the rectangle. But guess what? You'll eventually get to the same stuff I just wrote. Right? Antiderivative of f prime is f, and keep going. And you're going to get the same answer I got, but with a little extra work. So that's up to you. Okay, it says there is no point C for which f prime C equals the average rate of change. So the guarantee the mean value theorem doesn't work. Explain why the statement does not contradict the mean value theorem. It sounds like it does, right? The only way it wouldn't contradict the mean value theorem is if we weren't allowed to use the mean value theorem, okay? Now we're trying to find average f prime. Look at this graph. We're trying to find the average slope of this graph. We just connected the endpoints with a secant line, right? Now this is only applicable if it's differentiable the whole time, and it's not differentiable right here. So we need to explain that it's not differentiable there, maybe why it's not differentiable. And it's also not differentiable here. There's 2 points. So I think we got to identify both of them. So we're going to say there is no point C between -4 and 3 for which f prime of C is equal to the average rate of change does not contradict the mean value theorem since f of x is not differentiable at x equals -3 and x equals 0. Minimum, we could get into why they're not differentiable there. We could say, well, at -3, it's a vertical tangent. And then we could say at 0, the slope from the left is 0. The slope from the right is -2. And those don't agree. So the slope doesn't have a value there. It's undefined. But you definitely want to say it's not differentiable at these points, and that's why it doesn't contradict. That was only a point. Now, if you're like, oh man, this is hard, I don't know if I can figure this out. Fine, it's a point. You can still easily get your 5 if you lose that point. I mean, try, but it's not going to you don't waste a bunch of time on it, and don't let it stress you out because it's 1 out of 54 points. You need to be averaging 6 out of 9 on these to get a 5. You can lose 3 points on every one of these and still be really close to getting a 5. Losing 3 points on every free response question. So if this is the only point you felt sketchy about, whatever, it's fine. Do your best, keep going, but don't waste time on it. Don't let it affect you in a negative way. All right. Hope this was helpful for your next practice test.